So I have here 12 chocolates and 8 cookies. Let's divide the chocolates in such a way that all of it are divided into the same number with no excess. So first we can have 6 sets of chocolates having 2 chocolates per set. Or we can also have 3 sets having 4 chocolates per set. Or we can also divide it to 2 sets having 6 chocolates per set. And it can be divided by 2 sets, by 3 sets, or by 6 sets. Now let's divide the cookies in such a way that all of it are divided into the same number with no excess. It can be 4 sets having 2 cookies per set, and it can also be 2 sets having 4 cookies per set. Now, if we are going to share these chocolates and cookies to children, what is the highest number of packs that will be made if we put together the chocolates and the cookies with no excess? So we are going to combine the chocolates and cookies, and we're going to divide it with no excess. We can divide it into 2 sets of cookies and chocolates, or we can also have 4 sets with no excess. So you can see in the picture. The question is the highest number of packs. So 4 packs is the highest number of packs that will be made. But can we do this every time we are asked to find for the highest number of packs or the highest number of objects? Do we need to draw and divide it manually? It's so hard. So here's the easy way by getting the GCF, or the greatest common factor. The GCF of 2 or more numbers is the largest number that is a factor or divisor of each number. Now, how do we find the GCF using continuous division method? When you say continuous division method, it is dividing continuously until we get the correct answer, and it is a long division method. Here's the steps in finding the GCF. First, divide the numbers using a prime divisor until you get the prime quotients. When you say prime numbers, these are whole numbers greater than 1 that has only 2 factors, 1 and the number itself, such as 2, 3, 5, 7, 11, and so on. Next, you multiply all the prime divisors used to get the GCF. Now let's apply the steps in this problem for the 12 chocolates and 8 cookies. Let's find the highest number of packs by using the GCF using continuous division method. So we will write 8 and 12, and then the continuous division method symbol. Then you find a prime numbers that is divisible for both 8 and 12. So we can use 2. Then divide 8 divided by 2, you will get 4. And 12 divided by 2, you will get 6. Then you divide again another common prime numbers for 4 and 6. You can have 2. So 4 divided by 2, 2, and 6 divided by 2 is 3. For 2 and 3, there is no common prime numbers for these numbers, so you stop there. And to find for the GCF, you just have to multiply these numbers. So we have 2 times 2. Therefore, the GCF of 8 and 12 is 4. Same answer as we did it earlier in the first example.
Okay, so earlier we were able to group it into two sets as well, just like here in our solution, but that's not the greatest common factor because you can still continue it and you can still make four sets or four groups. Let's have more examples. Find the GCF of 15 and 30. So using the continuous division method, let's write 15 and then 30. Use the division method symbol. And you need to think of a prime number that is divisible by both 15 and 30. We can have 5. So 15 divided by 5, we have 3, and 30 divided by 5, we have 6. 3 and 6 have still common factor, which is 3, so you still continue. So the prime number for both 3 and 6 is 3. So 3 divided by 3 is 1, 6 divided by 3 is 2. So there's no common factor between 1 and 2. So let us multiply now the GCF, or find the GCF by multiplying these numbers 5 and 3. So the GCF of 15 and 30 is 15. Next, find the GCF of 18 and 36. So you write first 1836 and then you start dividing now by writing the prime numbers for both that is divisible by both 18 and 36. Do not forget to start with 2, 3, 5, or 7 to make it easier for you to divide. So for 18 and 36, we can have 2 or 3, but let's just use 2 first. So 18 divided by 2 is 9, and 36 divided by 2 is 18. So let's continue. We have 9 and 18. The common factor is 3. So let's divide 3. 9 divided by 3 is 3. 18 divided by 3 is 6. Another common number is 3 for 3 and 6. So we have 3 divided by 3 is 1. 6 divided by 3 is 2. So there's no more common factor between 1 and 2. So you can now multiply all the divisors here. So we have 2 times 3 is 6 times 3 is 18. So the GCF of 18 and 36 is 18. Next, let's find the GCF of 48 and 64. So the prime number for both 48 and 64 is, we can have 2. So 48 divided by 2 is 24, and 64 divided by 2 is 32. 24 and 32, there's still a common factor for that. We can have 2. 24 divided 2 is 12, and 32 divided 2 is 16. For 12 and 16, there is still common factor for 12 and 16, which is still 2. So 12 divided 6 is 12 divided 2 is 6, and 16 divided 2 is 8. Another, continue until there is no common factor. For 6 and 8, you can still have 2. 6 divided 2 is 3, and 8 divided 2 is 4. So for 3 and 4, there is no common factor. So you can now multiply all the divisors here. We have 2 times 2 times 2 times 2. The answer is 4, 8, 16. Therefore, the GCF of 48 and 64 is 16. Let's have last example before you do it on your own. Now, as you can see, in this example, we have 3 numbers. We have 4, 12, and 16. If we are going to find the GCF of 3 numbers, we make sure that the three numbers have the same prime divisor. So if it's just only two numbers that have the same prime numbers, then you end there. You proceed to the next step, which is multiplying all the divisor. Let's have this one. So we have 4, 12, and 16. So let's find the GCF of these three numbers. We have 4, 12, and 16. Their common prime number is 2. So we have 4 divided by 2, we have 2. 12 divided by 2 is 6. And 16 divided by 2 is 8. Now for 2, 6, and 8, there is still another common factor for these three numbers, which is 2. So 2 divided by 2 is 1. 6 divided by 2 is 3. And for 8 and 2, the answer is 4. So in this given number, 1, 3, and 4, there is no common number for these three numbers. So you end there. You proceed to the step 2, which is multiplying all the divisors. For we have 2 times 2 is equals to 4. Therefore, the GCF of 4, 12, and 16 is 4. We use greatest common factors all the time with fractions, and as fractions are used a lot in everyday life, this makes GCF useful.